Pythagorean theorem, it states that for any right triangle, the hypotenuse squared is equal to the square of the side lengths added. And the formula for that is a squared plus b squared equals c squared, where c is the hypotenuse. And so that means that a and b are the other two side lengths. So that means that if we look at our triangle, C is the hypotenuse, and we always want to identify which is C first. And that will always be the side length opposite to the right angle, always. Alright, so here's our first example. We've got 10, 24, and C on a right triangle. So we'll copy our formula, a squared plus b squared equals c squared, and we'll start plugging in our values. C is across from the right triangle, which means that a and b are the other two sides. And so we have 24 squared plus 10 squared equals c squared. And we'll start simplifying. 24 squared is 576 plus 100 equals c squared. 676 equals c squared. And so that means that the square root of 676 equals the square root of c squared. And we get that 26 equals c. However, that's a plus or minus square root. But a side length can never be negative. And so c is going to end up being a positive 26. Negative. C is 26 units. And there we go. For our second example, we get a word problem. We say determine whether 9, 12, and 13 can be the side lengths of a right triangle. So you should always start by drawing a picture, and you must always identify C still. We said C is the longest side length, so it's going to have to be 13. Alright, so that means that one of the legs is 9, one of the legs is 12, and the hypotenuse is 13. However, you can have two triangles in this situation. You can have 9 be the bottom leg or 12 be the bottom leg. Regardless, either one is correct. It's the same thing. Alright, and we're going to find out with our formula if this is a right triangle or not. If it's a right triangle, the two sides should be equal. And if it's not, they're not going to be equal. And this is another way to use the Pythagorean theorem to prove if triangles are right. Okay. Alright, 144 plus 81 is 225. 225 does not equal 169. And so this is not a right triangle. And why? Because 225 does not equal 169 by the Pythagorean theorem. And then depending on your teacher and how the question is worded, you're gonna have to write it out. Okay, so here are some practice problems. Let's say that you had a triangle, a right triangle, and that the hypotenuse was 16. One side length was 13, and the other side length was 14. Alright, so go ahead and pause the video and try it on your own. And then unpause it to see the solution. Alright, so like we said, 16 is the C value because it's the greatest value, so it has to be the hypotenuse. So like good math students, we're going to copy the formula and plug in our values, and then we'll simplify to see if this triangle is or is not a right triangle. We get that 365 does not equal 256, and so this is not example number 2. Let's say that you have this triangle. Find the missing side length. And once again, go ahead and pause the video and come back once you've tried. Alright, so again, we write our formula, make sure it's remembered in our brains. We plug in the values we have. We simplify. We get that 225 equals c squared. We'll take our square roots. And again, it has to be a positive square root, and so we get that the hypotenuse is 15 units. So, the question is, or well, the thought is, what happens when we start seeing patterns with our Pythagorean theorems? Some triangles will have the same values regardless of what you do. So if they're a right triangle and they tell you it's a right triangle and they give you 2 side lengths, you can figure out what the third one is without doing the Pythagorean theorem because of these 4 Pythagorean triples, which are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. And so what does it mean that it's a Pythagorean triple? Well, so let's say we had a triangle, a different triangle for each one of these. And I said that, oops, sorry about that, that it was a 6, 8, 10 triangle. And that next one is a 10, 24, 26 triangle. Or that the other one is a 16, 30, 34 triangle, and a 14, 48, 50 triangle. So what did I do? I multiplied all the side lengths by 2, right? I said 3, 4, 5. I multiplied them all by 2, and I got 6, 8, and 10. If I were to recognize that 6, 8, and 10 were all divisible by 2, and then I get a 3, 4, 5, that means it's based off of a Pythagorean triple. Same thing with this 8, 15, 17 one. I multiplied all the values by 2 to get my new side length values. And so if I were to recognize this, I wouldn't have to do the Pythagorean theorem. I wouldn't have to do 16 squared plus 30 squared equals 34 squared. I could just say, well, this Pythagorean triple times some constant equals the new side lengths of the new triangle. And if I multiply all 3 sides by the same constant, they're always form right triangles. And this way, you don't have to do the long way of the Pythagorean theorem and do all the work. So if this makes sense to you, go ahead and use it. If it doesn't, just stick with the Pythagorean theorem. Do your a squared plus b squared equals c squared. Not a big deal.